So alhamdulillah, we have finally wrap up topic 3. Okay, so today we are going to start topic 4, entitled Electrochemistry. Okay, so the title of this topic is Electrochemistry. Okay, so chemistry as usual involve chemical reaction, okay, where we have reactant and products. When we have electro at the beginning of the chemistry here, it means that the chemical reaction involved in the transfer of electron. Okay, so the focus is more on the electron transfer. All right. Okay, so we have only 5 subtopics. Like I said, this topic is the shortest topic in semester 2. Okay, and one good thing about this topic is that some of the content of this topic you have been taught ataupun you have been exposed to the subtopics. Okay, so it is supposed to be easier lah, because it's not something new. Some of it. Okay, all right. So we have redox reaction, galvanic cell. We have standard electric potential, non-standard cell potential, okay, and that this we have standard electropotential. That means the condition need to be at standard condition. So what are the standard condition? And then opposite to standard electropotential, we have non-standard cell potential, okay, and then lastly electrolysis ataupun electrolytic cell and its application. Okay, all right. So let's start with redox reaction 4.1. Okay, so these are the learning objectives that you should know. Okay, make sure that you are able to explain the characteristic of redox reaction. Okay, in terms of electron transfer and oxidation number changes. Okay, and then, secondly, make sure that you are able to write a balanced ionic half equation and net ionic equation using the method of half equation in acidic and basic solution. So this might be new to you guys. Okay, so you have to balance the equation. Normally we would balance the equation based on the number of atom on the reactant and the product side sahaja. But for redox reaction, you have to consider for the electron number. Okay, you need to also balance the electron number. Okay, because we are talking about redox reaction. So not only the number of atom present in the reaction, you also need to balance the number of electron. Okay, so that's the focus on this balance equation. Okay, balancing the redox equation. So redox reaction and oxidation state. Okay, so like I said, electrochemistry is the study of redox reaction, okay, that produce or require an electric current. Okay, this is the study of redox reaction. So redox stand for reduction. Okay, the word redox itself stand for, so we have redox here. So red stand for reduction, ox stand for oxidation. Okay, so we know these two relates on the transfer of electron. Okay, so it's a study of redox reaction that produce or require an electric current. So this basically the process of it. Okay, so it can either produce electric current or it requires electric current for the redox reaction to take place. Okay, so redox reactions involve the transfer of one or more electron from one chemical species to another. Okay, so this is reduction and oxidation. When this happens, oxidation state of atom will change. Okay, will change. Okay, so reducing agent, we have reducing agent and we also have oxidizing agent. Okay, reducing agent means the substance that undergoes oxidation. The word agent here maksudnya agent means penyebab. Okay, reducing agent adalah substance that undergoes oxidation. Dia menyebabkan, okay, reducing agent dia menyebabkan other substance reduce, but dia itself undergoes oxidation. Okay, itu maksud agent. Ni macam konsepnya, you want to go for a vacation lah, for example. Okay, you have money and then you hire a travel agent. Because of that, because of that travel agent, okay, you are able to travel overseas, for example. Agent tu, travel agent tu. Okay, same goes to reducing agent. Because of this reducing agent, it cause others to undergoes reduction. Tapi dia sendiri undergoes oxidation. Dia sendiri lost electron. Okay, so itu maksudnya reducing agent. Dia menyebabkan orang lain reduce tapi dia sendiri undergoes oxidation. Okay, same goes to oxidizing agent. Okay, it oxidize others, agent, okay? It oxidize others, but dia itself undergoes reduction. They gain the electron. So what happened to the number of the oxidation state? For reducing agent, the oxidation state increases. For oxidizing agent, bila dia undergoes reduction, the oxidation state decrease. Okay, the oxidation state decrease. Tu tak? Yes, increase in oxidation state. The oxidation number akan increase. Okay, oxidizing agent, dia sendiri undergoes reduction, so oxidation number will decrease. Okay. This is the dia punya formula of it, oil rig. Okay, so oxygen is loss. Okay, reduction is gain. Gain dengan loss in terms of apa? In terms of electron. Okay, alright. Then we have spontaneous redox reaction and non-spontaneous redox reaction. So just now you have been introduced to redox reaction. So what is reduction? What is oxidation? What is reduction? What is oxidation? What is oxidizing agent? And what is reducing agent? Okay, next we have spontaneous redox reaction and non-spontaneous redox reaction. The reaction itself, okay, the redox reaction itself, there are two types of reaction. Satu, spontaneous. The word spontaneous means it happened naturally. Okay, we don't have to put in any energy or whatsoever. Okay, it happens naturally. But non-spontaneous is the opposite of spontaneous. Yes, non-spontaneous lah maksudnya it won't happen unless you put energy to it ataupun you put effort to it, then only it can happen. Okay, alright. So spontaneous redox reaction takes place in a voltaic cell, or also known as electrochemical cell. So what happened in this spontaneous reaction is that the chemical energy of the substance, okay, will be changed into electrical energy. Okay, example, we have galvanic cell. So galvanic cell is an example of electrochemical cell. Okay, so this is how it looks like. This is how galvanic cell look like. As you can see, we don't have any battery. Tak perlu, we don't need any battery. We just need the cells. Okay, the substance that need to reduce and oxidize. So we have copper and silver here. Okay, so the electron will be transferred. Okay, whatever it is, the electron will be transferred because this is based on redox. Okay, so the electron transfer will be based on the the difference in potential. Okay, difference in potential. So dia akan terjadi secara naturally ataupun secara semula jadi, because between this copper and silver there is a difference in potential. Okay, Memang by nature pun macam tu. Macam you dengan kawan you memang akan ada that different in potential. You suka buat ni, kawan you suka buat benda lain. So that is another example that you boleh imagine, okay, the different in potential. Okay, so non-spontaneous on the other hand, example macam electrolytic cell. Okay, in electrolytic cell, electrolysis kan, in electrolytic cell by addition of electric energy. So it requires energy. So energy is normally provided in terms of battery. Okay, so the conversion of energy will be from electrical energy to chemical energy. So this is opposite to spontaneous. So the process involved ataupun this what we call that the cell, okay, that requires that perform this non-spontaneous redox reaction is known as electrolytic cell ataupun electrolysis process. Okay, so this is how electrolysis process. Okay, electrolytic cell looks like. So this is the battery. So we need the battery. Kenapa nak battery ni? Because it creates the beginning punya step. Okay, they pump the electron out, and from that it will cause the cell to start ataupun to function lah. Okay, for the transfer of electron. It's okay. This one will be covered later in the slides. Okay, at the end of the topic. So this is just to introduce to you the type of redox reaction. We have spontaneous and non-spontaneous. Okay, spontaneous, they change the chemical energy into electrical, tapi electrolytic dia terbalik. It requires the energy to change into chemical energy. Okay. Okay, so the difference between oxidation and reduction. Okay, ini you dah familiar lah with this one. You dah belajar dah last time, okay? Alright, so just to recap, oxidation, an element loses electron. Okay, dia hilang electron. So dia oxidize. Kenapa dia oxidize? Because it lost the electron. Okay, so dia remove the electron from itself. On the other hand, reduction, the opposite to oxidation, it gains the electron. It's like donating and accepting lah. Okay, alright. Oxidation, in terms of oxidation number, it will increases. Okay, for oxidation, but reduction, it will decreases. Okay, oxidation number, like for example, increases initially +1. After oxidation, they become +2. Okay, ataupun reduction, initially maybe +1. After reduction, they become 0. Okay, so this is reducing. Okay, decrease in oxidation number for reduction. Okay, the element is known as reducing agent, like I said just now. Okay, when it undergoes oxidation, it is known as reducing agent. Okay, dia menyebabkan orang lain reduce. That's why reducing agent, dia menyebabkan orang lain reduce. Tapi dia itself undergoes oxidation. Okay, same goes for reduction. The element is known as oxidizing agent. It causes others to oxidize, but dia itself undergoes reduction. Okay, right, and then other than based on other than method of identifying the oxidation process is satu kita identify dia lost the electron. Satu lagi bila dia adds oxygen increases. Number of oxygen atom added increases. So that is also an indication of oxidation reaction has taken place. Ataupun dia tambah oksigen dan dia lost hydrogen. Okay, dia lost hydrogen ataupun loses hydrogen. So this reduction should be the opposite of oxidation lah. Okay, the compound loses oxygen and gains hydrogen. Okay, not only the oxidation number decreases, it can also be identified in terms of the number of oxygen, okay, and hydrogen. Okay, and then here second last punya apa nama point here, a half equation has electron as product. Okay, look at the last example, the example of equation here. Okay, when we write the equation for oxidation reaction, the electron will be the product, one of the product lah. Okay, sebab normally dia macam ni, Cr2 plus, dia tolak elektron kan, sebab hilang oxidation kan, loses electron kan, so dia tolak elektron, so it becomes Cr3 plus. Jadi sebenarnya macam ni, but like I said last time, lama dulu, SEM 1 dulu, we don't represent tolak ni, kita selalu pakai tambah. Okay, so to change this one into plus, to transfer to the other side, so ini akan jadi tambah 1 electron on the product side. So that is why for oxidation, we have electron as the product. Okay, sebab dia oxidation kan, dia hilang electron. Okay, so then reduction should be the opposite of this one lah. Okay, so the electron, because they accepts electron, right? So they accept electron, so the electron will be will become the product. Will become the reactant. Okay, will become one of the reactant. So this is an example of half equation. Okay, half equation maksudnya dia fokus kepada reduction saja ataupun oxidation. And then later we have full equation. Full equation maksudnya is a combination between oxidation and reduction punya equation. Dapatlah full redox equation. Okay, so that ni saya nak highlightkan. Kenapa nama dia half equation? Because it focuses only on the reduction. This one, they focuses on only for oxidation. Okay. Okay. Oxidation number. So oxidation numbers also called as oxidation state. Okay. So oxidation number can also be called as oxidation state. It represents the number of electron. Okay, that an atom can gain, lose, or share when chemically bonding with an atom or another element. Okay, alright. So sometimes in order to form a bond, the electron need to be removed, or the electron need to be gained, or sometimes it need to be shared. Kan? So this will cause the oxidation state to change. Okay, this will cause the oxidation state ataupun the oxidation number to change. Okay, so this oxidation state atau oxidation number, it is a positive or negative number. Okay, it can be positive or negative number assigned to an atom or ion to show how it is bonded to another element in a substance. Okay. Okay, so the oxidation number is assigned according to a set of rules. Ada rules yang kita kena consider. Okay, so kita dah tahu dah rule tu. Cuba dia put in in a proper list lah supaya kita boleh kita boleh fokus. Okay, so some of it kita memang dah well known dah. Contohnya group 1, group 2, the oxidation state is positive 1. Okay, group 2 positive 2. Like oxygen, the oxidation state is equal to negative 2. Okay, so some kita dah tahu, some ada yang tambahan. So kita stop sekejap, azan. Okay, we will continue after this. Okay, all right, so let's continue. So we have a set of rules in order to determine the oxidation state of a substance, of a species. Okay, so let's go through each one of them. So kita ada in total 8. Okay, there are 8 rules in assigning the oxidation states. Okay, rule number 1, ini kita dah quite familiar with it. Okay, the oxidation number of any free element. Any free element is equal to 0. For example, sodium. So we have sodium and then chlorine. So what is the oxidation state for sodium? Okay, if it is in neutral state, that means dia bukan dalam bentuk ion, the oxidation state for sodium atom is 0. Okay, chlorine on the other hand, it is a molecule, right? But it is apa nama tu, as long as it is not in ionic state, so the oxidation state is equal to 0. Okay, so sodium atom is 0, chlorine molecule is also 0. Ini kita tahu. This one we have already familiar. Okay, with this one. Okay, and then rule 2. The oxidation number of any simple monoatomic ion. Okay, now we are talking about ion. For simple monoatomic ion, it is also equal to the charge of the ion. Okay, for example, sodium plus. Okay, the oxidation state for sodium plus is equal to the charge of the ion, which is positive 1. Okay, Cl minus. Now both of them become ion kan? So bila dia become ion, the oxidation state is the same as the charge, which is negative 1. Okay, alright, so macam ni dah halang-halang, lupa saya nak dekat contoh dekat sini kan. So sodium, since it is 0, okay, the oxidation state is 0. Chlorine is also 0. Okay, because you notice there's no charge kan. The oxidation state is the same as the charge, which is 0 lah. Okay, alright, so sodium chloride is also 0. No charge kan? So 0, 0, 0. Jadi kena balance on the reactant side and the product side. Okay, both of them need to be the same. So reactant side we have 0, product side is also 0. Okay, alright, so sodium chloride again. So sodium, so once it becomes sodium chloride, we know that sodium come from sodium plus. Cl come from chloride minus. So sodium plus, sodium is positive 1, chloride is negative 1. Betul tak? So the apa nama tu, when we total this, okay, ini kan sebenarnya so kosong for sodium chloride is also for is also 0. So the total will be 0. Sebab sodium chloride is the combination of sodium and chlorine. How about sodium chloride yang this one? Okay, yang this one dia dalam bentuk ion. Okay, dia dalam bentuk ion. So sodium is positive 1, right? Plus chloride is negative 1. Okay, so when we total these two, kita dapat 0, which is the same as the charge of sodium chloride itself. Okay, so tapi ni tak ada product reactant ke apa, tak ada lah kan. Yang this one we have an equation. Still we can check. Okay, okay, that is number 2. Number 3. The sum of all oxidation number. Dia tak tunjuk lagi dekat sini, tapi saya dah beritahu awak. Dekat sini rule number 3 baru dia beritahu. Okay, the sum of all oxidation number of the atom in a neutral molecule mass equal to 0. So, saya dah tunjukkan yang tadi kan. So kalau sodium plus is positive 1, chloride minus is negative 1. So how about sodium chloride punya oxidation number? What will it be? So what is the oxidation number for sodium chloride? So basically we can combine, okay? So sodium, this is sodium plus, it's positive 1, chloride minus is negative 1. When we total these two, we got 0. Okay, alright. B, okay, neutral, dia kena sama, neutral molecule mass equal to 0. Because we are talking about neutral molecule. The charge is 0. Okay, alright. So how about if it is a polyatomic ion. So how do we determine the oxidation number for polyatomic ion? Sama juga. Okay, so the sum of all the oxidation number, kita akan sumkan, totalkan all the oxidation number of the species in the polyatomic ion, and it must equal to the charge on the ion. Okay, it must equal to the charge on the ion. For example, NO3 minus. So what is the oxidation for NO3 minus, guys? Okay, alright. So normally it will be the same as the charge of the polyatomic ion. Tapi macam mana kita justify? How do we prove that it is equal to -1? Okay, alright. So nitrogen, the oxidation number is +5 plus, okay, kita totalkan, total means tambah lah. Oxygen, kita ada 3 biji oxygen, and then the oxidation number of oxygen is -2. So when we total these two, kita akan dapat -1. See, bukan ke sama dengan NO negative and NO3, the charge is the same. So it is justified. The charge is the same as the oxidation number. Okay, faham ya? Alright, so that is rule number 3. Rule number 4. Group 1 metal have an oxidation number of +1 in all their compounds. Okay, alright, so group 1 and group 2 lah, the most famous metal group in periodic table. Okay, so the oxidation state for group 1 will be the same as dia punya charge. Okay, for all of group 1 members. So sodium plus the oxidation number is +1. Potassium, okay, the oxidation number is also +1, and so on. Okay, alright. So this is the same as earlier part, yang rule number 2, if I'm not mistaken. Okay, okay. Yang rule number 2 tu dia nak introduce ion, but this one, rule number 4 ni dia nak introduce in the form of group 1, group 2. Okay, yang rule number 2 tadi, yang kita belajar tadi, dia nak introduce in general the ion. Okay, ion. So ion dia punya oxidation number, how do we determine the oxidation number? Okay, 4 dan then number 5. Oh, dia jadikan rule number 5 Okay, group 2. Tadi saya combine kan kat rule number 4. So dia asing, dia separate. Okay, group 2 metal have an oxidation state of +2 in all their compounds. So for example, magnesium, okay, so the charge is +2, which is also equal to its oxidation number. Okay, alright. Then rule number 6, guys. Rule number 6. Okay, for hydrogen. How about for hydrogen? So what is the oxidation state for hydrogen? Okay. For hydrogen, assign the oxidation number as follows. Okay, so for hydrogen alone, dia ada its own step. Dia ada few steps yang you kena consider dekat situ. Okay, because hydrogen, dia depends dengan who the hydrogen combines with. Okay, then banyak possibility kan. So if the hydrogen combine with non-metal punya species, it will form a covalent hydride. Okay, so we know that non-metal, it is more electronegative. Betul tak? Non-metal punya karakteristik like group 17, group 16, 15, they are all more electronegative than hydrogen. Betul tak? Okay, in that case, okay, so the oxidation number of hydrogen should be for +1. Okay, dia akan jadi +1, bukan jadi -1. So what interesting about hydrogen adalah dia boleh jadi +1, it can also be -1. Dia macam mana nak tahu +1 ke -1? It depends dengan who dia bind with ataupun dengan whom dia combine with. Okay, kalau dia combine dengan non-metal, for example, HCl kan. Cl, we know that Cl is -1 kan. So H will automatically be positive 1. Oxygen, H2O. Oxygen, we know that oxygen is negative 2, right? Okay, so hydrogen should be positive 1. Okay, cuma dia ada 2 biji lah. Dia ada 2 ketul. Tambah dengan negative 2. Okay, and so on. NH3, H2, SO4, OH minus. So this shows that hydrogen, when it combines with non-metal, it will carry the positive 1 oxidation number. Okay. What if bila dia combine dengan metal? Because we know that metal is more electropositive. Betul tak? Macam sodium, magnesium kan? They are all carries positive oxidation number. Memang nature, okay, memang nature of the metals, they tend to undergo oxidation. So in that case, hydrogen will carry the negative 1 oxidation number. Dia akan jadi hydride. Okay, dia akan jadi hydride. Just now dia jadi hydrogen saja. Dia akan jadi dia akan carry the positive 1. Okay, this one pun still hydride tapi dia akan carry negative 1. For example, if they combine dengan lithium. So we know that lithium will carry the positive 1. So hydrogen in this case, okay, or also known as hydride, it will carry the negative 1 oxidation number. Okay, so dia boleh berubah-ubah because after all, hydrogen has only 1 electron. It can either accept another electron or it can remove the only 1 electron that it has. Okay, either one pun dia still boleh, dia become dia boleh berada dalam kedua-dua keadaan. Okay, because of that 1 electron yang dia ada. Dia fleksibel lah, boleh buang, boleh accept. Okay, macam orang lain ada banyak elektron kan. You cannot simply buang all the electron. No, okay. It requires a lot of energy to do that. So that's why orang lain tu normally dia fix. Kalau dia positif macam sodium kan. Sodium is metal kan. It has 11 electron if I'm not mistaken. So it tend to move atau it tend to remove the outermost electron. Okay, so that's why dia jadi positif. Bila jadi positif, hydrogen kena jadi negatif. Okay. Rule number 7. So done with hydrogen. Now oxygen. Okay. This hydrogen dengan oxygen is very important because based on number of hydrogen dengan oxygen, kita boleh determine whether the process ataupun direction is oxidation ataupun reduction. Okay. So that's why kita kena tahu pasal hydrogen and also oxygen. It indicates whether the reaction is a reduction process ataupun reduction reaction ataupun oxidation reaction. Okay, so done with hydrogen. Next, we have oxygen. Pun sama juga. The same characteristic for oxygen. Kita ada few possibilities for oxygen. Okay, so normally the most common one kita tahu the oxidation state will be the same as the charge of oxygen. Normally oxygen will be negative 2 kan, oxide. Ini yang paling common lah, betul. Dia tak salah. Tapi there are other possibility as well. Okay, alright. So let's look at A. The oxygen number of O ataupun oxygen in oxide is negative 2. Kalau dia oxide, dia adalah negative 2. Okay, for example, if sodium combine dengan oxygen, so sodium, we know that sodium is very positive kan, so oxygen will be negative lah, will carry the negative charge and negative oxidation number. Same goes to be AO, H2O and so on. So this is normal lah, ini yang paling common. Okay, another example if other than negative 2, it can also carry other oxidation number ataupun other oxidation state. Okay, so dalam peroxide, oxygen in peroxides. Okay, oxygen in peroxides. So this is the chemical formula of the ions. Okay, O2, 2 negative. So yang this is oxide kan? So you must know what is the difference between oxide, peroxide, and then later we have superoxide, guys. Okay, so beza dia kalau peroxide dia ada O2 tapi still, sorry, dia kat belakang saya nak negatif 2. So this is peroxide. Okay, dia sama tapi this one dia ada 2 oxygen atom dekat situ. This is peroxide, guys. The charge is the same but the number of oxygen atom present is 2, not 1 like what we have in oxide. Superoxide on the other hand, superoxide still O2 but the charge ataupun dia punya charge, charge dia sekarang jadi -1 ataupun negatif lah. Okay, this one like this, O2. So this is superoxide, guys. Make sure that you are able to differentiate between these 3. Okay, so tapi all the charge ataupun all the oxidation number semuanya negatif because it shows that oxygen is like what I've said, oxygen is one of the most electronegative atom in periodic table. Okay, so 3 option yang kita ada ini menunjukkan dia carries the negative oxidation number. Okay, so please be careful. Species related to oxygen, it can be oxide, the normal one. It can also be peroxide, and it can also be superoxide. Okay, so these are the example of oxygen in superoxides, superoxide and peroxide. Okay, condition. Okay, dia ada 2 ni nampak. 2 dekat situ. So 2 dekat sini. So ini 2, kalau kat sini 2 ni jadi 2 dekat sini. Maksudnya kalau you darab silang positive 1, this is negative 2 kan. So this is peroxide. Okay, this is peroxide. This is peroxide, and then how about this one? This is BaO2, -2. This is superoxide, guys. Okay, this is superoxide. Sebab dia maintain ada 2 dia tu. Maintain ada 2 tu. Sini positive 2, right? So this is -1. Because dekat sini nampak tak? Dekat beryllium dia kan ionic kan? Bila ionic kan you kena darab silang kan? Dekat Ba ni tak ada 2. So dia ada 1 Ba saja. So macam mana berjaya macam tu? Because the charge ataupun the oxidation number is -1. The charge lah. When we are talking about ionic, okay? Dia darab silang tu, dia Ba carries, bukan Ba, the O2 ni, the charge is -1. Okay? Alright, so this is peroxide.
Madam.
Yes.
Apa yang rule number 5 tu kan? Apa tu, dia memang group 2 je yang ada.
Sorry, number 5?
Yang rule number 5 tu. Dia memang group 2 je yang ada.
5, dah ke belakang number 5. Sekejap.
Itu.
Group 2 metals have an oxidation state of U. Dia assign for group 2 saja kat sini. Yang rule number 4 dia assign for group 1 saja. So dia macam dah separate lah kan.
Macam mana dia punya charge tu boleh letak kat depan?
Dia punya charge?
Dia punya charge tu boleh letak kat depan tu. Macam MJ tu plus ni, macam mana 2 plus ni boleh ada kat depan dia ni?
2 plus boleh ada kat depan. Ni? Tak, ni dia nak tunjuk oxidation number untuk Mg2 plus berapa? Positive 2. Dia nak beritahu oxidation number for Mg2 plus is equal to positive 2. This one, oxidation number for sodium plus is equal to positive 1.
Jadi yang NaCl tu tak apa?
Yang mana? Yang this one? Untuk apa?
Sebelah yang NaCl yang bawah tu.
Bawah ni?
Bawah lagi.
Bawah lagi, ni.
Ini, ya jadi kenapa dia letak?
Example. Maksudnya kalau dalam NaCl ni, the oxidation number for sodium berapa? Positive 1. Okay? The oxidation for the oxidation state for sodium berapa? Positive 1, which is ni lah apa yang dia cakap ni tadi lah. So they apply. This is the application of oxidation state yang dia baru bagi tahu tadi. So they apply. Okay, in sodium chloride. Okay, in sodium chloride, the sodium in sodium chloride, the oxidation state is +1. Okay, chloride is -1. So samalah dengan apa yang dia bagi statement tadi. Okay, contoh ni contoh dia lah. Maksudnya in sodium chloride, so the oxidation state is +1. For this one, magnesium chloride, kan dia baru bagi statement. The oxidation state for Mg2 plus is equal to +2 kan. So, kalau kita nak, contohnya, kita ada compound. Okay, the compound is MgCl2. So, how do we determine the oxidation state for Mg in MgCl2? So, based on this rule, Mg come from group 2. So, this Mg in MgCl2 is the oxidation state is equal to +2. Betul tak? So, Cl tadi kan rule number berapa tadi? It is -1 tapi dia ada 2 biji. That's 2 darab 2. So, tambah. So, bila kita totalkan, kan dia dapat MgCl2 kan neutral molecule kan? Dia 0. Dia punya oxidation state dia. Charge dia is equal to 0 kan. Bila you totalkan this one, macam mana you dapat 0? So, bila you totalkan, you see, you dapat 0. It's the same. Okay. So, this is application lah yang dia bagi cok. This is contoh. The application of it. Faham? Faham tak?
Faham.
Okay. Okay, let's proceed with oxygen just now. Oxygen ada extra one rule dekat situ compared to hydrogen. Okay, so ni dia depends dengan siapa dia combine with. Did you know that oxygen can also, the oxidation state for oxygen can also become +2? Okay, so this is very rare lah, tapi ada this possibility. The normal one will be these three lah. Yang paling normal will be oxide. Because all of them carries negative oxidation number. -2, -2, -1. Semua ni negatif. Yang C ni pula, dia special sikit, dia boleh jadi +2 guys. Can become +2. When dia combine with, agak-agak dia combine dengan siapa? Kalau dia terpaksa jadi positif, yes. Kalau dia terpaksa jadi positif, as we know, fluorine, oxygen, nitrogen, these are the 3 most electronegative atoms. Okay, kalau based on ranking, fluorine is most electronegative, followed by oxygen, followed by nitrogen. Okay, so kalau dia terpaksa jadi positif 2, that means dia kena combine dengan the most electronegative atom, which is fluorine. Okay, sebab fluorine the king lah, the king of electronegative kan, species. So when it combine with fluorine, dia akan carries the +2 oxidation number. Fluorine on the other hand, sebab dia most electronegative kan, will remain with the negative oxidation number. Okay, dia ada reason kenapa dia jadi positif tu lah. So this is very unlikely. Oxygen tak suka tapi dia terpaksa. Bila perlu dia akan jadilah. Okay. Okay, so that is C for oxygen. So done. That we have 3 consideration that we have to consider for oxygen. Okay guys. Okay, last but not least, rule number 8 for group 17. For group 17 element, assign the oxidation number as follows. Okay, like I said, fluorine, chlorine, bromine and all dengan dia punya adik-beradik, all the sibling from group 17. Okay, so group 17, what is the most electronegative group in periodic table? Okay, so most electronegative group, I'm talking about group. So kalau fluorine dah the king of electronegative species, that means fluorine will always has -1 oxidation number. Okay, other halogen, okay, dia pun sama, it will carries the -1 oxidation number, chlorine, bromine and iodine kan. when they occur as halide ion in their compound. So normally these three will carry the negative oxidation numbers. Tapi again dia depends dengan siapa dia combine. When they combine with oxygen. Okay, when they combine with oxygen, dia kalah lah. Because oxygen, dia bawah fluorine. Okay, dia bawah fluorine. So, oxygen is considered electronegative as well. So, automatically, this is called oxy and ions. Okay, bila dia ada oxygen, it is called oxy and ion. When it combine with oxygen, automatically the halogens, okay, will have positive oxidation number. Okay, it will have positive oxidation number, positive 1 lah. Okay, you can check each one of them. HClO4, ClO4 ni contoh lah, kita check this one. Okay, we can check this one. But this one ada hydrogen kan. Ini, okay, Cl, apa nama tu, if oxygen, okay, oxygen is negative 2. Dia ada 3 ketul kat situ. Okay, Cl kita tak tahu, assume that we don't know whether it is positive or negative oxidation number kan. So X plus negative 2 because it is an oxide. Okay, and then we have 3 oxygen atom in there. And then the charge is negative 1. So that the overall oxidation number for ClO3 minus is negative 1. Okay. All right. X. The oxygen number of halogen bukan positive 1 dia adalah X is equal to this is negative 6 kan. The negative 6 transfer to the other side dia jadi positive 7. Betul tak? Betul kan? This is negative 6 transfer to the other side dia jadi
5, madam.
5. Ish. Positive 5. Okay, dia jadi positive 5. So, dia akan carry the positive oxidation number. Okay, depending on whom it combines with. Tapi normally dia memang carry the negative 1 charge. Tapi lah kalau dia combine dengan oxygen, dia combine dengan fluorine. So, dia kena carry the positive oxidation number. Okay? Okay, jom try example. Determine the oxidation number for sulfur in the following compound. Okay, alright. Maksudnya bila kita nak determine this one, yang ini kita kena tahulah. Okay, that's why dia bagi tu in the sets of rule just now, dia bagi yang common punya species. Contohnya group 1, group 2, oxygen, hydrogen, halogen kan. So because those are the species yang senang nak combine untuk jadi compound. Okay, jom tengok. Sebenarnya kita dah tahu, kita boleh straight away tahu dah sebenarnya kalau kita cepat. Kita tahu sodium positive 1, oxygen negative 2. So kita boleh terus buat positive 1 for sodium kan. Ada 2. Okay. And then sulfur, since kita tak tahu, let's just make it X plus oxygen. Okay, kita tahu it is negative 2. Kita ada 4 of it is equal to, the charge is 0 kan, because it is a neutral molecule, substance kan, 0. So determine lah X will be berapa. Okay, same goes to B. Tapi kalau kita nak with reference to the rule that we have learned just now, they go through lah setiap satu tu. Okay, the oxidation number of each sodium ion is sodium plus. It's the same as its ionic charge, which is positive 1. Dia beritahu, nak relate dengan apa tadi, dengan rules yang kita dah belajar. The sum of the oxidation number in the neutral compound to be is 0. The charge dia punya tu the sum of oxidation number, 0. Okay, and then they kata, there are 4 oxygen atom and the oxidation number of each oxygen is -2. This is rule 7A. Okay, when we combine all of these, we total up, we got S is equal to +6. Okay, S is equal to +6. And this is just for checking, guys. Okay, this is just for checking. You masukkan +6 tu dalam this one. And this, you masukkan, you dapat tak 0? You manage to get 0 tak? Kalau you manage to get 0, that means your final oxidation number is correct. Okay, ini untuk checking yang last ni. Untuk checking, make sure yang you dapat tu, dapat tak sama dengan 0 bila you insert into this equation. Okay, right. Same goes to NH4 okay, ammonium sulfide. So this is what we call ammonium sulfide. Okay, there's few ways for you to solve for this one. You either separate them. Okay, as you can see, it can be separated into NH4+. Okay, because the whole thing is equal to +1. Ataupun you nak buat secara individual, it's okay. Okay, mana-mana pun still acceptable. Okay, kalau solution as what we have here, dia tunjuk dalam bentuk ammonium ion. Okay, ataupun you nak buat macam ni pun boleh, nitrogen. Okay, jangan lupalah ni darab masuk nitrogen. Nitrogen is +5 kan? Sorry, nitrogen. Oh, so ni dia nak determine the nitrogen punya. Okay, faham. Dia nak determine the nitrogen punya, what do you call that? Oxidation state. Okay, nak determine the nitrogen punya oxidation state. Sebab dalam rule tu kita tak ada. Kan, dalam rule untuk nitrogen we don't have it kan. So macam mana, how do we solve for this one? Okay, one of the method is, okay, kita solve dia based on polyatomic ion. Okay, NH4+. NH4+. So bila kita solve for NH4+, macam ni. Kita assume kita tak tahu nitrogen berapa. Kita asingkan dulu. Kita buat for NH4+ dulu. Kita tak tahu nitrogen berapa. But we do know about the oxidation number for hydrogen. It is +1. Because kenapa dia +1 bukan -1? Sebab dia combine dengan non-metal nitrogen. Okay. So dia +1. So dia ada 4 ketul dekat situ. So this is an ion kan, and this is polyatomic ion. So dia punya overall oxidation number is +1. So you selesaikan, you akan dapat for nitrogen. See, dapat untuk nitrogen. So it is -3. Bila -3, barulah you boleh buat macam yang tadi tu. Okay, so nitrogen and H, you baru boleh combinekan sulfur kan, betul tak? Okay, alright. So baru you boleh buat asingkan. Okay, so nitrogen just now yang kita cari -3 tambah dengan hydrogen, dia ada 4 ketul, dia +1, right? Don't forget this 2 darab 2 dekat situ. Sulfur kita tak tahu, and the overall is equal to 0. Okay, alright. So you nak cari X. X is the S lah. Is for sulfur. So X is equal to -2. Okay. Tapi steps ni dia ada extra steps sikit dekat atas tu, because we want to confirm on the oxidation number for nitrogen dulu. So how do we confirm for nitrogen first? So kita boleh asingkan dia dalam bentuk ion. This one. Okay, bila you asingkan dalam bentuk ion, you jangan confuse lah. Nanti kan confuse sebab dia ada 2 kat sini kan. Nanti you carry dengan dua-dua. Tak. You nak yang ni je yang ion dia. So this is NH4+. Yang 2 ni kita akan buat dekat sini. Kat bawah ni bila nak determine the oxidation number for sulfur. Okay. So unless you dah tahu beforehand nitrogen is -3, okay lah, you boleh lah masuk terus je cari sulfur. Kalau you pun tak confirm, sebab dia boleh berubah nitrogen. Tiba-tiba dia combine dengan siapa? Dia combine dengan Cl ke? Dia combine dengan Cl, dia jadi positif. Okay, dia combine dengan Cl, dia akan jadi positif. Sebab kita tahu Cl dia electronegative group kan, so it will carry the negative oxidation number. Okay. Okay, checkpoint guys. Cuba buat checkpoint ni. Cuba try checkpoint. Any question? Okay, please do ask. Okay, please try this checkpoint. Okay, alright. So let's discuss. Are you done, guys?
Yes, dah.
Okay.
Yes.
Yes, madam.
Yes.
Yes, madam.
Yes, madam.
Yes, madam.
Alright. Thank you.
Yes, madam.
Respond. Okay, very good. Okay, so let's discuss. Determine the oxidation number of manganese in MnO4 minus. In this one. Okay. Alright. So you have to take into consideration the rules that we have learned just now. Kena consider all the rules kat situ. Okay, manganese. Manganese kan. So manganese kita tak tahu Okay, so you can either put Mn ataupun assign sebagai X is both also okay. Okay, oxygen. Okay, this is an oxide. So oxide ni the most common one lah. Superoxide dan peroxide ni dia bukan very easily can be formed tau. So don't worry so much on that. Tapi you kena tahulah. Okay, and then superoxide dengan peroxide ni dia ada tendency to form dengan certain element saja. Not everybody can form compound with superoxide dengan peroxide. Okay, sebab superoxide dan peroxide ni dia quite unstable. Kalau dia di form, bila dia dissociate, dia become unstable. Okay, but this is different compared to kalau nak compare dengan oxide. Okay, because that's why oxide the most common ionic state for oxygen. Okay, alright. So this is oxide -2. So we have 4 of them. And then it is equal to the charge ataupun the overall, the total oxidation state for the species. It is -1. Okay, alright. So dapatlah manganese berapa? This is -6. Betul tak? Negative. Macam mana boleh dapat -8? This is -8. When you transfer to the other side, you jadi positive, then you got +7. Okay? Alright, +7. So the answer will be +7 lah, this one. Okay, the oxidation state is +7. State which element undergoes oxidation and reduction and justify. Okay, alright. So kita kena check before and after. If you want to identify to indicate the oxidation and reduction, you have to identify the before and after for each species in the reaction. So iron 2+, initially it is +2, later it become +3. As you can see, the oxidation number increases. Therefore, that is the characteristic of oxidation. So iron, okay, that undergoes oxidation. Which element undergoes oxidation? So it should be Fe2+. Be specific, guys. Don't just simply use Fe. Okay, this is wrong. Don't use Fe3+. This is also wrong because dia tanya yang undergoes oxidation. It should be Fe2+. Tolong jangan buat Fe. Okay, this is with respect to the reaction. So please be specific. Sebab dia boleh jadi Fe, Fe2+, Fe3+. Masa tu, bila you kata Fe, there's no Fe in the reaction, in the equation. So salah lah Fe tu. Okay, alright. So the answer is Fe2+. How about reduction? So manganese lah. Okay, so we have to check for manganese. Initially, it is +7 kan. After it undergoes reduction, it is reduced to +2. So the oxidation number is reducing. So that is the characteristic of reduction. Tapi siapa yang undergoes reduction dekat situ? You kena answer Mn7+. Okay, so please be specific, guys. Okay, Mn7+. Okay, identify oxidizing agent and reducing agent. Ni nak terpening-pening sikit kan. Dia tanya agent. Bila tanya agent, it would be the opposite of the reaction that the species undergoes. Okay, dia terbalik. Sebab dia agent kan. Okay, so okay, so this one tadi oxidation, iron 2+ oxidation, that means dia Fe, dia become Fe juga kan. So dia lah agent dan dia sendiri yang undergoes oxidation. So kalau kita start dengan reducing agent lah. The answer will be Fe, okay, Fe2+. Okay, and then oxidizing agent. Yang ni yang dia agak ni sikit oxidizing agent. Sebab dia ada carrier dekat sini. Dia tak stand alone. The manganese, okay, dia tak stand alone. It has oxygen with it. So, but the one that undergoes oxidation adalah manganese. The one that undergoes reduction adalah manganese. Tapi we are talking about agent. So bila agent, we have to take it as a whole. So oxidizing agent, you kena beritahu it should be MnO4 minus. Agent, the whole thing. The whole thing. Okay, tapi the one that undergoes reduction is only manganese. This is the one that undergoes reduction. But when we are talking about agent, you kena consider for all of them. Macam travel agent company. Okay, so dia kena consider overall. Tapi the one that undergoes, yang buat kerja untuk pekerja-pekerja yang buat kerja supaya orang lain dapat travel adalah pekerja dia. Inilah pekerja yang undergoes reduction. Okay, right. Tapi Fe ni dia memang dialah sendiri yang agent dan dia juga yang undergoes oxidation. Okay, right.
Madam.
Ya. Question.
Untuk yang second question tu kan, in terms of justification, kalau kita explain untuk Fe2+, kita tahu dia undergoes oxidation sebab dia increase of oxidation number. Tapi for untuk Mn7+, is it okay if we mention pasal dia undergoes reduction sebab dia loses oxygen?
Loses oxygen.
Sebab kita tahu
boleh?
Kalau
boleh? Obvious kan dekat sini kan, maksudnya we have 4 oxygen and then after the reduction, okay, there's no oxygen at all. Okay, tapi boleh tak salah sebab kita kan ada karakteristik of reduction dengan oxidation tu kan. Tapi usually kan dia punya priority lah. Okay, priority they will go for oxidation number. Okay, the change in oxidation number. Normally kita akan go for that. And then kita punya supporting will be the number of oxygen present. Okay, so it will be good for you to have both characteristic in your answer. Sebab normally kita akan start dengan oxidation number dulu. Tapi dia macam ni. You dah triggered kan, bila you nampak MnO4 initially dia ada 4 oxygen and then later dia tak ada oxygen. So you boleh tahu that it should be oxidation lah. Okay, manganese undergoes reduction sebab loss of oxygen kan, the loss of oxygen, so that is the characteristic of reduction. And then you try to prove it using oxidation number. You mesti kena dapat decreasing oxidation number. Okay, sebab normally soalan akan either dia bagi general tapi ataupun dia suruh prove it using oxidation number. Okay, so best to have both of them in your answer. Okay, ya, tadi ada nak tanya lagi? Ke nak tanya soalan yang sama tadi? Dia macam ada 2 soalan.
Soalan yang sama, madam.
Okay, alright. Okay, alright. So this one, Fe, reducing agent, see, Fe2+, okay, MnO4 minus is the oxidizing agent. Okay, ini kan Fe. So statement dia, you be careful Kan tadi saya kata you kena specify Fe2+ kepada Fe3+. Tapi this one is not wrong. Kenapa? Sebab dia specify Fe is oxidized from +2 to +3. So this is also correct. Even though dia cakap Fe, tapi dia cakap from apa kepada apa. Okay? So this is also correct. Yang problemnya adalah bila student kata state which element undergoes oxidation. Fe. Tu je jawapannya. Salah. Ni salah. Okay. So kalau you ada explanation, Fe is oxidized from +2 to +3. Then it's okay. Okay guys? Okay, done. Next, moving on to balancing redox equation. Tadi tu is like the introductory part of redox reaction lah. So this is the real deal that normally I would say like 80 to 90% will be coming out in exam. Okay, for topic 4, balancing redox equation in acidic or basic solution. Kita nak start balance the equation. Okay, tadi kita just nak macam bagi warm up sikit. What is redox and how do you determine the oxidation number, the before and after, how do you determine whether it is reduction or oxidation. Okay, so those are considered as introductory part of redox reaction. So now is the real deal. Kita nak balance the redox equation. Okay, like I said, you have to consider the number of electron. Okay, because this is about the transfer of electron. Okay. Jom, many redox reaction takes place in aqueous solution. So normally the redox reaction will take place in aqueous solution. So the half equation are balanced separately. So how do we balance it? How do we balance the redox equation? So kita kena separate. Okay, the half equation. So like I said just now, half equation meaning that we have oxidation and we also have the reduction. So we separate them into two so that it will be easier for us to focus on these two equation. Then later on we can simply combine total je lah kan. Then combine to the fully balanced net ionic equation, the overall equation. So in this method the reaction is separated into two half equation, oxidation and reduction. So each half equation consists of electron on the product side for the oxidation, electron on the reactant side for the reduction. Okay, so kita separate, senang nak buat kerja, asingkan dia. Let's look at the example. Okay, balance the following redox equation. So this is like, kata general equation lah. This is not even specified in whether dia nak acidic ataupun basic. Ini sebelum tu, this is like to balance the normal equation involving redox. Okay, alright. So how do you balance this redox equation? As you can see, kalau kita based on the coefficient lah, normally kan kita balance on the coefficient because kita kena make sure that belah kiri dengan belah kanan dia kena sama dia punya number of atom kan. Ini dah balance. See, Fe sama, Sn satu dekat on reactant side, Sn satu dekat product side. Okay, but as you can see, the oxidation number are not balanced. Oxidation number dia, kalau you tengok dekat sini, this is positive 3, this is positive 2, this is positive 2, this is positive 4. Bila you try to balance, ni tak balance ni. This is positive 5, this is positive 6. So this is not balanced. Okay, so bila oxidation number ni, it has something to do with electrons. So we have to balance the number electron first. Okay, so that's why saya kata redox ni bukan saja kita kena balancekan the number of atom species tu sendiri. We have to balance the electrons. Okay, the charge. Alright, so the first tip is to separate them first, okay, because this is not balanced. Daripada mata kasar nampak macam balance, tapi kita tengah cakap pasal redox, dia tak balance lagi. So in order to separate them into two, kita kena identify siapa oxidation, siapa undergoes oxidation, siapa undergoes reduction. So how do we do that? Senang, tengok before and after. Okay, iron initially it is positive 3. Okay, once it undergoes the is either oxidation atau reduction, dia become positive 2. So it is reducing. Reducing perangai siapa? Oxidation. Okay, perangai reduction. Okay, itu perangai ataupun karakteristik of reduction. Kita kan nak kena asingkan kan? Okay, so kalau iron ni dah reduction, that means stannum ni apa panggil ya? Stannum apa lah? Dia punya alternative name?
SN ya.
SN apa? Kalau Ag silver kan? Stannum.
Tin lah, madam.
Tin. Okay, tin. Okay, tin. 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 Nak cakap lagi. Tin. So tin, Initially it is +2, they become +4. So increase in oxidation number. So bila dia increase oxidation number, that is the characteristic of oxidation. So you asing dulu siap-siap. Okay, bila you asingkan, okay, ni dah asing This is oxidation, this is reduction. Oxidation, reduction. Okay, alright. So kita nak balancekan the charge ataupun the oxidation number. So kita asingkan dulu. Okay, so bila kita dah asing oxidation, tin 2 plus on the left hand side, +2. Okay, on the right hand side, we have +4. Betul tak? So this is not balanced. Dia tak balance. +2, +4. So this is not balanced. Tak boleh. Dia kena kasih sama. It need to be balanced out. Okay, so how do we balance this +2 dengan +4? So kita add in electron. So where should we place the electron? Since this is oxidation, remember oxidation should be placed, the electron should be placed on the product side. Okay, it should be placed on the product side ataupun electron should be the product of oxidation. Sebab dia buang elektron kan? Bila buang elektron, the byproduct is electron. So that's why elektron tu kena duduk dekat produk. Itu satu. Satu lagi, macam mana kita nak, normally bila kita tambah elektron, kita ada oxidation number yang tinggi, +4, kita nak kurangkan dia jadi +2. So how do we reduce from +4 to +2? Kita tambahlah electron because we know electron, the charge is negative. Betul tak? So how many electron need to be added? So we have to add in 2 electron because 2 electron will carry the -2 charge. Okay, alright. So +4 plus -2 is equal to +2, and eventually it is now the same. So this is considered balanced lah. Sn2 plus equal to Sn4 plus 2E. This is already balanced for oxidation, guys. Already balanced. The charge is balanced. So the same approach you saw for iron. Okay, so iron undergoes reduction. That means it accepts electron. Okay, guys. Okay, so initially it is +3 and then becoming +2. So as you can see, it is not balanced. Tak balanced. So how do you balance it? Okay, so macam mana you balance kan? So you kena tambah elektron lah. Tambah elektron tahu nak tambah dekat produk ke nak tambah dekat reactant. Satu indication menunjukkan reduction. Reduction dia mesti accept. So dia kena duduk dekat reactant side. And then satu kita nak reduce kan from +3 nak jadi +2. So kita kena tambah elektron dekat tempat yang banyak oxidation number. Okay. Alright. So kita tambah dekat reactant side. We need only 1 electron. So we add in 1 electron. So +3 plus -1 that come from the electron just now. So we got +2. So it is now the same. It is now balanced. So once everything is balanced, next step is to combine. Okay, we combine the equation, both equation. However, okay, you must notice bila kita buat equation, kita tak display the electron, betul tak? Mana ada kita buat equation, even redox pun. Redox means the combination of reduction and oxidation equation kan. You don't have electron display in the final equation. Tak ada. Maksudnya it need to be cancelled out. Okay, it need to be cancelled out. Ni electron ni, the half equation tak apalah kita display. Tapi for overall equation, we do not display the electrons. So it need to be cancelled out. So in order to be cancelled out, the number of electron need to be the same, betul tak? The number of electron need to be the same. Tapi kita dah boleh nampak pattern dia. For oxidation, we have 2 electron on the product side. For reduction, we have only 1 electron on the reactant side. So dia tak boleh total cancellation guys tu. We will have balance of electron. So we do not want that. Okay, we do not want electron to be present in the overall equation. So in order to cancel out, okay, to have a total cancellation, kita kena times with an integer. Okay, macam biasalah lah. Macam kita buat Hess law, thermochemistry last time. Ingat yang Hess law tu, ataupun kita buat chemical kinetic yang kita nak combinekan the intermediate and whatnot kan. Kita kena darab 2 kan, nak manipulate tu. It's the same thing. Okay, alright. So for this one, kita kena times 2. Okay, the reduction equations because we want the electron to become 2 electron. When we times 2, bukan simply darab 2 dekat electron tu kita kena times everything with a factor of 2. So it will become this one. This is the final one. Okay, so you dah ada, okay, so dah 2 electron. This one pun 2 electron, product side. This is reactant side. So it can be cancelled out, total cancellation. See, you cancel, and then you combine. So this is the balance redox equation. Okay, so dia ada 2 dekat sini. Initially, this is the initial one. Ni tak balance. Okay, so finally, this is the balanced version. So we have 2, a factor of 2, okay, at the front of iron 3+ and also iron 2+. Okay, so not all step above is called as skeleton equation. So these are the step. Ini dia punya working solution. Ni. And this one just now. Okay, these are all skeletal. Kita consider skeletal equation, but the one that question wants is this one. Ni working solution dia. Tapi normally untuk balance equation, maximum 5 marks. Okay, minimum will be 3 marks. Itu soalan jenis macam ni. Okay. Okay, that is a simple version of balancing redox equation. Next, ini yang normally yang soalan suka tanya lah, like exam. You have to balance the redox reaction in acidic and also basic solution. Okay, alright. Acidic and basic lah. Maksudnya kalau acidic, there is a presence of H+. Basic, on the other hand, there's a presence of OH-. Okay, alright. So H+ or OH- ion play an important role in many redox reaction. Okay, so the product of a redox reaction is based on the acidity of the solution. Okay, so many many times, in order for the redox reaction to take place, the pH of the solution is very important. pH as in whether it is acidic ataupun basic. Okay, so dia somehow dia membantu the reaction. It cannot be neutral. So it need to be in acidic ataupun in basic. So that's why dia kata play an important role in many redox reaction. Okay, so that is why you have to know how to balance the redox reaction in acidic and basic solution. So the method used are slightly different in order to balance redox reaction in acidic and basic solution. Okay, sebab kita kena consider the acidic and basic, the H+ dengan OH-. Tapi the concept, okay, the steps are basically the same as what we had earlier just now. Asingkan dulu, kena determine which one is the oxidation, which one is the oxidation dengan reduction. Okay? Okay, cuba tengok yang ini. Contoh soalan. Balancing oxidation reduction equation in acidic medium. Okay, in acidic medium. So this is the equation that is given to you. You have to balance it out. Okay, so as you can see, this is not balanced in terms of the charge, the oxidation number. Okay, zinc 0, this is 2+. 0, this is -1, this is +2, this is +4. So this is +1. Okay, ini overall secara seni lah, nak tengok yang dia confirm lah dia tak balance. That's why soalan suruh ni balance saja, saya nak provekan yang dia ni tak balance. Okay, alright, so dia memang tak balance lah tu. Okay, so first step, when you have this equation, you have to separate into oxidation and reduction. So how do you separate this into oxidation and reduction? You kena determine the oxidation state. Okay, alright. So luckily di oxidation dengan reduction, kalau dia ada lagi satu tahap Persian, kan leceh sikit kan. So once you have determined this one, katakanlah zinc undergoes oxidation, automatically the other species will undergo reduction. Kan? So dia mempercepatkan proses bila dia ada dua option je. Either kiri atau kanan. Kalau dia bukan kiri, dia kanan lah. Okay? Macam Le Chatelier's principle kita kan last time. Okay, so zinc initially it is 0, after dia jadi positive 2. So this is obviously oxidation, increase in oxidation number. Okay, but this one, ni kita kena check. Ini panjang sikit dekat sini. Okay, ini panjang sikit. Sebab kita kena check siapa yang undergoes dalam NO3 ni, which one undergoes reduction. Obviously nitrogen lah. Nitrogen akan undergoes reduction. Okay, lagi satu banyak indication lah menunjukkan initially dia ada 3 oksigen, tiba-tiba all the 3 oxygen has been replaced with 4 hydrogen. So that is the characteristic of reduction. Betul tak? Tapi kita nak tahu. Like I said, normally kita nak tahu in terms of oxidation number. Okay, initially berapa, after dia berapa. Kalau exam kan, soalan tanya, okay, determine the oxidation number change for species that undergoes reduction. Macam tu soalan cakap. Okay, so you kena determine the one that undergoes reduction, what is the change in oxidation number. Okay, alright, so nitrogen, so, jomlah kita buat. Okay, ni dia dah beritahu dah, positive 5 becoming negative 3. Tapi how do you get positive 5? Sama macam what we have learned earlier. Okay, so nitrogen kita tak tahu, kita ada oxygen is negative 2, darab 3, so total charge is negative 1. Betul tak? Okay, so bila you transfer to the other side, you akan dapat positive 5. Okay, nitrogen, at the beginning, the oxidation number is positive 5. Same goes to NH4+. Okay, you do the same way as this one, you will get negative 3 lah for nitrogen. So as you can see, it is decreasing, is it? Yes, the oxidation number is decreasing from positive 5 to negative 3. Okay, alright, so you can separate into 2. Okay, so this one is oxidation, this one is reduction. Okay, separate dulu into 2. Okay, ni step number 3 is very, very important. Okay, sebab this is for acidic ataupun basic. Okay, so kita asingkan kepada 2. So kita buatlah side by side ke. Depends lah nak buat atas bawah ke kan. Kita go for oxidation dulu. Tak kisahlah nak go for oxidation ke reduction. Okay, okay, so look at step number 3. Balance other atom first except oxygen and hydrogen. Okay, so you have to balance other atom first except oxygen and hydrogen. For example, let's look at the zinc. Okay, so kita kena consider the number of atom on left hand side dengan product side. That is what orang kata basic untuk nak balance the equation. Kita kena make sure dia balance dulu. Okay, ini dah balance, it's not a problem. Because dia satu zinc dekat kiri, satu zinc dekat kanan. In terms of the atom itself, in terms of the species itself. Okay, so kalau dia tak balance, contohnya macam dia ada benda lain kan. So you kena balancekan first. Okay, alright, so then B. Okay, since A dah balance oxygen atom. So kita nak balancekan oxygen atom by adding H2O to the side of the equation that needs oxygen. So kalau dia missing in oxygen, for example, look at reduction punya proses. Okay, nitrogen dah balance. Cuma oxygen on the left hand side kita ada 3, tapi on the product side we don't have oxygen at all. Nampak tak? Tak balance kan? On the product side we don't have oxygen at all. So how do we solve for this one? So dia kata to balance oxygen dekat tempat yang tak ada oxygen, we are going to add in H2O guys. Tambah H2O, bukan tambah O2, bukan tambah O, dia tambah H2O. Faham? Ni syarat dia, you kena add in H2O. But this reaction is conducted in an aqueous solution. So it need to have water lah in it. Okay, so you need to have water in it. That's why you have to tambah H2O, not to tambah oxygen gas, not to tambah ion or whatsoever. You have to tambah H2O on the side of that equation that needs to that needs oxygen. So kita akan tambah dekat product side lah. That's the idea of it. Nanti kita tengok contoh sebab dia bagi statement ni dekat sini. Contoh dia dekat belakang. Okay, ingat. Nak balancekan oxygen, kena tambah H2O. And then, how about hydrogen? Okay, again, look at the reduction equation. Okay, on the product side, we have 4 hydrogen. But on the reactant side, we don't have hydrogen at all. Tak ada hydrogen. So, how do we balance this hydrogen? So, tapi untuk hydrogen, you kena tambah H+. Okay. You kena tambah H+. Sekejap. Ya, ni tadi kan kita dah tambah H2O kan dekat sini kan. You dah tambah H2O kan. So, dia dah ada hydrogen. Tapi kat sini still tak ada hydrogen at all. So, how do you add in hydrogen? So, you kena tambah H+. Tambah H+, ya. Not H2O, not hydrogen gas. No. Okay, you have to add in H+. Follow the instruction. On the side that needs hydrogen. Okay, which is on the left-hand side lah kat sini. Okay. Okay, let's look at example kat sini Okay, so kita dah asingkan oxidation, reduction. Oxidation is not a problem because dia tak ada oxygen, tak ada hydrogen. Basically, dia just nak kena balance in terms of charge saja. Charge je tinggal and then dia dah balance. Okay, in terms of atom, hydrogen ke oxygen is not a problem because dia memang ada zinc saja. Okay, simple. But this one you have to consider. So this is the original version of the equation just now. Okay, so since kita identify on the reactant side, kita ada 3 oxygen, right? Tapi on product side, we don't have oxygen at all. Nampak? Tak ada oxygen at all. So how do we add in oxygen? We have to tambah the H2O. Tambah H2O So how many of it that need to be add in? So since we have 3 oxygen here, right? So we are going to tambah 3 H2O. Senang, kita terus balancekan in terms of coefficient right away. Okay, alright, settle for oxygen first. Next, we go for hydrogen. Okay, next we go for hydrogen. Okay, so NO3 minus. So since on the product side we have hydrogen, but on the reactant side we don't have a hydrogen at all. So we are going to add in H+ on the reactant side. So how many of H+ that need to be added? Kita kena totalkan lah. Kita totalkan ya. Alright, so here we have 4 hydrogen and here we have 6 hydrogen. See, 3 times 2, we have 6. 6 plus 4 is equal to 10. So we have to add in 10 H+ on the reactant side, guys. On the reactant side, because dekat reactant side we don't have the hydrogen. Okay, alright. So first kita kena balancekan the coefficient of the atom first before kita go for dia punya charge, dia punya oxidation number later. Okay, alright. So now semua dah cukup. Nitrogen ada 1, oxygen ada 3 on the reactant side, on product side, ada 3 juga. Okay, and then hydrogen we have 10 on the reactant side, on the product side we have 10 also. So in terms of coefficient, all of them have been balanced. Okay, dah ready. Now they are all ready. Okay, next step, we have to balance the charge, the oxidation number. Okay, balance each half fraction with respect to charge. Macam biasa, by adjusting the number of electron. Okay, alright. So tadi kan, macam saya cakap zinc to plus no problem. So we need to balance the oxidation number. Okay, that is all. Then the equation is now ready. Okay, so zinc initially it is 0. Okay, once they undergo oxidation, it become positive 2. Obviously, this is not balanced kan? So this is not balanced. So how do we make it balanced? So since this is oxygen, so kita kena tambah on the product side. So the electron will become the product. Okay, so kita tambah macam mana? Berapa banyak nak tambah? Okay, how do we make it the same? Sebab electron, dia punya charge is negative. So how do we reduce from positive to, maybe kita boleh reduce kepada 0. So that's why kita tambah 2 electron on the product side. Okay, so dah ready. Okay, dah ready for oxidation. So this is now balanced lah. This is 0. This is positive 2. This is negative 2 kan. Bila you totalkan these two, you akan dapat 0. 0 is equal to, 0 is equal to 0. So dia dah balance lah. Okay. It is now balanced. Okay. Now go for reduction. Sama juga reduction. Okay. Alright. So this one is negative 1. Okay. Kita consider the charge je. Negative 1. This one 10 plus 10 times positive 1 is positive 10. Okay, negative 1. Tak payah nak consider nitrogen ke apa, tak perlu. Dia just kita consider the charge saja, the overall charge. Okay, negative 1, positive 10. This one, positive 1. This is 0 kan, 0. So, positive 9 dengan positive 1. This is not balanced. Obviously, this is not balanced. So, how do we make it balanced, guys? So since the reduction kan, so kita kena add in electron on the reactant side. So how many electron need to be added? So we are going to add in 8 electron. Okay, so this just now is positive 9, and then we have 8 electron, which is we have negative 8. Okay, so here we have positive 1. So positive 1 minus negative, positive 9 minus negative minus, sorry, positive 9 plus negative 8. Kita akan dapat positive 1, which is the same on the product side. So it is now balanced. Okay, alright, dah balance. Barulah kita nak kena apa nama tu balance electron between half fraction. Okay, kita nak combine kan. We need to combine both equation. Like I said, kita kena consider the number of electrons. So the electron will not be present in the overall equation. So it need to be cancelled out. Tapi the problem is not. The problem here is the number of electron is not the same for oxidation and reduction. Di ini kita ada 2, this one kita ada 8. Bila kita combine, nanti kita akan ada baki of electron on the reactant side. We don't want that to happen. Okay, therefore kita kena multiply with a factor. Selalunya kita multiply dengan yang sikit lah. Sebab kebetulan dia boleh factorize kan. So 2 dengan 8. Oh, kita boleh times 4. Kalau tak boleh factorize, macam biasa kita kena darabkan dia lah. 8 darab. Katalah dapat nombor-nombor. Katalah sini bukan 8. Ini bukan 2. Ini 7. 7 elektron. This one 8 elektron. So you akan kena, yang ni darab 8, yang ni darab 7. So 56 elektron. Okay, jangan terkejut ada yang beratus-ratus elektron So it's not a problem because it will be cancelled out. Tapi yang dia punya ni, coefficient dia tu akan jadi besar-besar. Okay, ada, boleh. Tak salah, jangan risau. Madam, saya dapat 105 ni madam. Provided you punya step ni betul. Dan betul lah 105 yang awak dapat tu. Okay, 105 coefficient dia. Okay. Alright, so you multiply with a factor of 4. Okay, and then you got 8 electron for the oxidation. So now they are now ready to be combined. Okay, so electron need to be cancelled out. And then, so berhati-hati guys sebab nampak ada banyak sangat ni. Ada banyak benda yang you kena consider. So please be careful when you transfer ataupun when you rewrite each species in the overall equation. Daripada hujung ke hujung, please be careful. Jangan tertinggal dia punya charge. When you tertinggal you punya charge, you terus hilang satu markah tu. Gone. Okay, so please be careful. Okay, so you transfer. So this will be the final equation. So this is in acidic condition. How do we know so? Because the presence of H plus. Okay? Ya, itulah steps yang kita akan lalui in order to produce balance equation in acidic condition. Okay? Okay, what if the question asks in basic medium ataupun in basic condition, guys? Okay, maksudnya bila basic, you boleh imagine just now we have H plus. Okay, for basic, that means we are not going to have H plus. We are going to have OH minus. Okay, alright. So by using the same equation that we have here, tadi sama. Okay, the best thing is we are still going to be using the step 1 until step 5. Tu yang bestnya. Kita pakai step yang sama. Okay? Alright, so dekat sini. Kita pakai, in fact sampai ke akhir kita pakai. Kita still pakai, kita memang kena lalu acidic condition dulu. You dah dapat this final equation, right? This is the same as acidic just now. This is the final version, but the final equation, but in acidic solution. So how do we make it basic, guys? How do we make it basic? Okay? Right. Ni cara dia. Nak jadi basic, senang nak tambah OH je. Okay, so how much of OH minus need to be added? Okay, we are going to refer to the number of H plus present in the equation. Since we have 10 H plus on the reactant side, right? So we are going to add in the same coefficient for OH minus. But, okay, we are going to add in on both sides. Jangan tambah sebelah je, kita kena tambah dua-dua. Bila you buat editing ataupun alteration, you kena consider on both sides. Okay, you have to add in the same coefficient that we have for H plus just now. Okay, kita add in the same OH minus, the same coefficient for OH minus, which is 10 OH minus on both sides. So 10 OH minus dekat reactant side, 10 OH minus dekat product side. Okay, ini kalau basic ya. Alright, so you pun tambah. You tambah. Satu benda yang you kena consider adalah bila H plus combine dengan OH minus, it will produce water. Okay, how much of water will be produced? It will produce 10, the same coefficient lah, the same amount of H plus dengan OH minus, which is 10 H2O of water will be produced. Okay, alright. Yang ni tak ada siapa-siapa boleh cancel dia. So dia remain as is. Okay, OH just now. So this one bila dia combine H plus OH minus, it will produce 10 mole of H2O. Tapi bila ada 10 H2O, ada H2O, bila dia combine jadi H2O, one thing you kena consider adalah ada dua spesies yang sama on reactant and product side. So it cannot be that way. Kita kena cancel out, betul tak? Dia tak boleh ada dekat produk dengan reactant side compound yang sama ataupun spesies yang sama. Dia kena either on product side ataupun on reactant side. So dia tak boleh. Ini unsettled. Okay, it need to be settled lah. Okay, so okay, kita kena consider. Okay, on reactant side we have 10 H2O, right? On product side we have 3 H2O. Initially memang kita ada 3 H2O just now. Okay, so bila you kena, yalah, baki ni dekat mana? So 10 H2O is more than 3 H2O, right? So we are going to minus. And we have baki, we have balance of H2O on reactant side. But this one akan jadi kosong lah. Dah tak ada lah H2O. So that's why we have 7 H2O on the reactant side only. And we don't have H2O on the product side. Okay, dah settle dah. Itulah. So this is in basic condition because we have OH minus in the reaction. Tak ada siapa yang boleh cancel this OH minus. Okay, so this is considered balanced redox reaction in basic solution. Okay, so dia ada notes, should not appear in overall balance equation. The electron should not appear in overall equation. It's just that you have to be careful lah. Okay, student punya common mistake adalah bila dia nak salin balik. Dia kat atas tu dah buat cantik. Bila dia salin balik dekat bawah tu for the overall, dia tertinggal charge lah. Dia punya coefficient tertinggal lah. Dia salah tolak lah. Common mistake. Sebab dia panjang kan. Daripada hujung ke hujung. Ni belum deal dengan ni. Tu belum lagi tulisan besar-besar. Okay, tak dapat nak satu line kan. Dah terpaksa ke bawah. Bila ke bawah dah jadi macam beberapa line. Dah confused guys. Tu belum lagi tulisan buruk. Okay. Tulisan buruk dah tak faham. Dah bercampur-campur. Please guys. Okay. Siapa yang punya tulisan yang agak kurang kemas ataupun huduh. Tolong perbaiki. Okay. Moment examiner tak faham. Kita reject je you punya answer. Right. Okay. Alright. So maybe you can try out this checkpoint 2. Cuba try checkpoint 2. Okay, nak bagi you warm up sikit. Nak bagi refresh sikit the steps that we have for in balancing the equation. Cuba try buat dulu. Okay, cuba try. Nanti kita buat sama-sama. First step, asingkan dulu. Okay, separate into two as oxidation and reduction. Okay, buat dulu. Any question so far? Boleh tanya? Okay, dah siap ke? Guys, dah sampai
Hi,
mana?
madam.
Udah?
Madam.
Okay, dia just follow steps je kan. Kalau you ingat step tu, yang the rest pun untuk soalan-soalan lain pun, okay. So you are going to be using the same steps. So step make sure H2O and then H+. Lepas tu balancekan, combine, make sure cancel out the electron, and then make sure that there is H+ if it is in acidic, and if it is basic, you have to make sure that you have to add in OH minus. Okay, and then make sure when H plus dengan OH minus, it will produce H2O. So H2O need to be cancelled out on the reactant and product side. So normally we would have balance lah. Ada juga possibility yang dia kebetulan sama reactant dengan product side of H2O tu sama. Cancel, tak ada H2O dah. Ada. Okay, ada that possibility. Okay, jom kita go through the solution. Separate dulu, okay. So the obvious one will be iron kepada iron 3+. So kalau chromium tu you kena standby. Normally kan soalan akan tanya ada extra question dekat situ. Determine the number of oxidation number for chromium. The change in oxidation number for chromium. The change, bila cakap change, you kena daripada apa kepada apa. Bila dia kata change. Okay, maksudnya from initially it is +3 becoming +6. That is what it meant by change. Okay, alright. So this is, I mean, not justify. Okay, that both of them, one of them is oxidation, the other one is reduction. Kita kena go for oxidation number. Tapi kalau dia tak tanya, kita identify satu, automatically the other one will be if this one is oxidation, then this one should be reduction lah. Okay, itu lebih cepat lah, lebih cepat. Tapi kalau tengok soalan, kalau dia insist for oxidation number for chromium, manganese, what else? Selalunya yang transition metal lah, yang you have to determine the oxidation, the change in oxidation number. Okay, so once you have separated them into these two equation, the time to balance each equation. This is time for you to balance the equation. Okay, iron again is not a problem because dia tidak ada hydrogen, dia tak ada H2O, dia tak ada hydrogen and oxygen. Okay, so leave it as is. So this one for the reduction, kita kena follow the steps lah. Okay, follow the steps that we have learned just now. Ini kebetulan dia bagi iron. Ada juga dua-dua pun kena melalui proses yang sama, kena tambah H2O, kena tambah H+, and then balancekan, and so on. Okay, ini kebetulan dia satu simple, the other one is a little bit complicated. So ini yang you akan dapat. Okay, so you tambah H2O dulu. How many of oxygen that need to be added depends on the number of oxygen present on this side. So we have 7, so kita akan tambah 7 H2O. So therefore we have 7 oxygen. Then next baru H+. Okay, baru tambah hydrogen in terms of H+. How many of H+ that need to be added dekat side yang tak ada H+. You kira dekat sini lah. 7 times 2, 14. So there should be 14 H+. Okay, so this is now ready for the next step, which is to balance the electron number. Okay, alright. So ni macam biasa, you boleh asingkan lah. Kalau you nak buat macam ni pun boleh. Kalau saya prefer oxidation and then reduction. Okay, balancekan dia punya electron, balancekan dia punya electron. Kalau tak muat, oxidation, and then bawah reduction, and then last combine. Okay. Okay, so mana tadi? Okay, this one. Okay, so +12 dengan +6. So as you can see, this is not balanced. So you nak balance kan, you kena tambah electron lah on the side that have more oxidation number on the left hand side. After all, this is reduction. They kena accept the electron. So kita kena tambah 6 electron. Okay, so +12 plus -6, kita akan dapat +6. And at the end, it is the same on both sides. Okay, alright, so we have 6 electron here. And For oxidation, we have only 1 electron. So obviously kita kena make it the same. So this one kita kena times dengan 6. Okay. This one kita kena times dengan 6. Ion ni. This one boleh remain lah. Okay, so cancel out. So you did this. This is for acidic solution. Basically your acidic solution dah ready. Okay, alright. So next step is dia nak for basic kan. We are going to add in the same coefficient for H plus ni untuk OH minus. Okay, so we are going to add in 14 OH minus on reactant and product side. Okay, alright. So on product side is not a problem sebab dia ada OH saja. We don't have H plus. But on reactant side, you have to be careful. You make sure that these two need to be combined into producing water, the same amount of water, 14 H2O. And then lagi satu, you kena consider, okay, dekat kiri ada H2O, dekat kanan pun ada H2O. See? So dia tak boleh display dua tempat, dia kena display satu tempat. So yang mana yang paling banyak? Paling banyak ada dekat reactant side. So 14 minus 7, you have a balance of 7 H2O on the reactant side. Okay, so nampak, this is the final one. So we don't have H2O on the product side. Okay, so this is the basic. This is the redox equation, balanced redox equation in basic solution. Dapat tak jawapan sama? Check sebiji-sebiji, jangan tertinggal any charge ataupun coefficient. Berjayakah anda?
Dapat.
Bagus, tahniah. Berjayakah anda mendapat sebiji-sebiji sama, even the arrow should be the same, okay? Arrow dia tu pun. Susunan tak kisah, yang ni dulu ke belakang ke, doesn't matter. As long as dia punya species that present on reactant side dengan product side should be the same. Dengan you punya jawapan, bukan ni kena depan belakang kena sama tak. Okay, so do we have? Okay, so that is all for balancing the redox reaction. So you may practice. I believe that we have more question in tutorial. Okay, so dah belajar kan? Cepat-cepat practice buat. Okay, so that you boleh ingat terus. Nak exam kita tinggal lagi beberapa minggu lagi nak exam. So cepat. Jangan tangguh-tangguh. Okay, alright, so next will be governing. So as you can see, we don't have time. So we are going to cover this one tomorrow during our 2 hours lecture. Okay, alright. Itu saja for today. Any question before we end our session?
No, madam. No,
Okay.
madam.
Alright,
Sorry,
so Gus, if there is no question, I think that is all. So thank you everyone for your attention and Assalamualaikum. See you tomorrow. Bye-bye.
Thank you, madam.
Thank you, madam.